All right.
All right, Mr. Lewis, and now for another exciting video in AP Statistics. You ready?
Always.
This really is a quick one. We got one example and one journal assignment. We want to go over the t-test again. So inferences with means.
Yes.
Hit it.
All right. So here we have a college student who's on a meal program, as you will all be shortly.
Wait, stop. How was your meal program at U of I?
Well,
Did you brown bag it? Did you get pizza all the time, or did you actually go to the cafeteria and eat their food?
I went to the cafeteria and ate their food.
You're still alive?
I am.
Any abnormalities?
No.
Okay, good sign. I lived at my folks' home, so it was good. I just raided the fridge when I was a freshman in college. All right.
So his budget allows him to spend an average of $10 per day for the semester. He keeps track of his daily food expenses for 2 weeks. He found the average for 2 weeks was $11.40, with a standard deviation of $8.05. Big standard deviation there.
Sometimes he ate well.
Yeah.
Went to Chipotle sometimes.
Is there strong evidence that he will overspend his food allowance?
So what would that mean? That he spends more than average?
Yes.
So we're testing his spending is actually more than 10.
Right. So our
Right.
HO. Right.
So first step.
So
we didn't mark out the steps, but we'll be following the steps in our solution here. So first step, state the null and alternative hypothesis. So this is about population mean.
Right.
That's what he's using mean.
all right. So first step. All right.
Maybe you can put a 1 over there. So first step.
Fine.
All right.
All right. So our mean is equal to 10. Our alternative, it's bigger than 10.
He's overspending. Okay.
Right.
2, state the statistic or the test we're doing.
Okay. Well, we're gonna use. It was only for 2 weeks, so it's only like 14 things. So we're gonna use a t-test.
Yep.
And also, the only standard deviation we have is for the sample. That's
Yeah.
another clue to use the t-test.
Right.
All right.
I mean, if it's like more than 50, you can do the z-test like you just don't care.
Right.
The reason why if it's more than 50, t and z are very, very close to being the same thing.
And we want to test the mean.
Okay. So either name the test. That's the name that's on the calculator, t-test. It's number 2 on the list of tests. Or state the t-statistic in its formula. Step 3. This is important.
We gotta check the conditions.
Check the conditions. Was this a random sample?
Not really.
Yeah, not really. So we're fudging a little bit here.
Yes.
So this is how we put this. We are assuming that these 14 days are representative.
Right.
So random sample would be the best. Like if he kept his receipts for a year and took a random sample of the receipts, but that would be hard for him to do. So we're assuming that they're representative.
Right.
Remember, random sample is the best way to get a representative sample. But we're assuming that even though it wasn't random, it represents the population. All right. The next condition is the 10% condition. Where these, well, since it wasn't a random sample, 10% condition doesn't mean a whole lot.
Right.
That has to do with whether it was with replacement, without replacement. So again, we're assuming this 10%.
Yes.
This is representative. Now, the nearly normal condition.
Okay.
Boy, this is tough too. Normally, we got to check that the sample kind of looks like a normal curve. That there's no skewness and no outliers.
Right.
Were we given anything about that?
No, we were not.
Yeah. So we're doing this test with a little bit of hesitation, or at least letting you know ahead of time that there's some assumptions we're definitely making that we'd want to know more about.
Right. I mean,
Okay.
if we were real big statisticians, we'd want to do more testing just to make sure this is working.
Yeah. So the random sampling, the 10%, and the fact that the sample is nearly normal. The reason why the sample has to be nearly normal, because to use the t-distribution, you're assuming that the original population was normal. Okay. So, all right. All right. Well, we have some hesitations there, but we'll perform the test.
Okay. So
Now, the fourth step is compute the statistic and the p-value. Show the mechanics.
right. So remember, it's x bar minus mu over s divided by square root of n. And let me try and make a better s. Here we go.
Okay.
So
X bar was,
11.4.
and we're assuming the mean is 10. That's our assumption.
Our standard deviation was 8.05, and we are dividing that by the square root of 14, because that's 2 weeks, 14 days.
Yeah. Needs are every day of the week, right? Not just Monday through Friday.
Right. So 7-day-a-week plan.
Okay, I got it in there.
Okay, what's our T?
0.65. Now, T is a
Point
distribution a little bit
6.
different than the Z-score, but it's still not that extreme.
Mm-hmm.
All right, so let's calculate a p-value. So that's the problem. Now, we should draw maybe still a little sketch. This is a right tail test, right? At least that shows you you're calculating the right tail. Hi, Ms. LaJoy. We caught her. All right, so this is a right tail test. So we just go second, distribution,
Yep.
T CDF. So maybe you can write down T CDF.
T, C, D, F.
The first thing it asks you is for lower limit. So that would be the 0.65 since this is a right tail. Upper, put in something huge. Bye, Miss LaJoy.
Bye.
And then the degrees of freedom.
Was 13.
Yeah, n minus 1. Okay. I paste it. And p-value is 0.263. There's a 26.3% chance. Is that shockingly unusual?
No.
No.
Not at all.
So,
That is very normal, very
Yeah.
usual.
so there's no real reason to believe that change our minds that he's spending more than $10 on average.
Right. So, step 5, we would fail to reject.
Okay.
Bam.
And then we would state in conclusion.
Right.
All right, those are the 5 basic steps.
Uh-huh.
All right, cool.
It'd be nice if we wrote those down somewhere.
Yeah.
Hey, look at that.
Oh, yeah.
So,
And this is kind of true for any hypothesis test, wouldn't you say?
yeah.
So since we've done this a lot now, we're really getting into this pattern.
Mm-hmm.
Okay.
So, you guys now, we have a lab testing 40 reduced sodium hot dogs.
To eat them?
The lab found that the mean sodium content is 310 milligrams with a standard deviation of 36 milligrams.
Mm-hmm.
The hot dog companies claim sodium content is only 300 milligrams. Something's fishy.
Yeah.
Is there significant evidence that the sodium content is actually more than the companies claim? So then,
Can we bust the company? Can we bust them?
Exactly. So we have all 5 steps there. So just make sure that when you do this, you're doing all 5.
Mm-hmm. And use sentences when stating your conclusion and in context, right?
Yes.
Okay.
All right.
All right,
Sounds
good luck.